This is called the step function or piecewise function. You see that there's a function, sorry, this is y, not x. Y equal, or f of x equal, we talked about this mean the same thing. F of x and y mean the same thing. So there's a function, it's equal to 2x. And there's a function equal to 2. There's two functions there, but it's written like under one. And here's the condition. That's where it tells me where to start and where to stop. These, if. That's, you cannot go beyond that. So let's first of all graph the function here. And let me graph f of x equal 2x. So how would we graph a function that it's f of x equal to 2x? Remember, there's nothing here, so it's plus 0. There's no y-intercept, so I add the 0. That means the y-intercept is at 0, 0. And then the slope is 2 over 1. So I'm going up 2 and right 1. So here's my function. The graph of that function. The graph of f of x is equal to 2x. Or y equal to x. Or f of x equal to x. So I graphed using a slope and y-intercept. You don't have to. You can make a short table to graph it. But it's not. This is, if I graph this is from negative infinity to positive infinity. It's telling me x can be anything from negative infinity to positive infinity. But that's not true. This is telling me where to start and where to stop. This is only true if x is less than 0 or equal to 0. So I'm going to look at my function and see where that x is less than 0 or equal to 0. If I see there's this part only, that it's less than 0, x being negative is this side, so it's that part of the graph, and equal to 0. So I'm going to stop right there. I'm going to erase all that. That's your y equal to x now. Only there. Now, if it's equal, you're going to choose closed circle, bubbled circle. So that's the only part of the graph that I need to cover this condition. Y equal 2x. If x is less than 0 or equal to 0, it's just going to be that bubbled circle. If I have to graph the second one, they have to be open circle on the top of it. Or it's not going to be correct. Remember, the piecewise has to be one of them a closed circle, the other one has to be open circle. They have to carry on. One of them closed, one of them open, and it continues with this pattern until you finish your open interval. From where to where? Now, how would I graph f of x equal to? How would I graph function like that? Remember, this is just y equal to 2. These are the special lines we have. This is your y equal plus or minus b. It's a horizontal line. It's a y-intercept at 0 plus or minus b. And then the slope. Of course, if you remember that, if you want to add it to your notes, slope is equal 0. So these are the information that you need to remember about your special lines. Either x will equal plus and minus a, and that's your vertical line. Or y equal plus and minus b, and that's your horizontal line, and it's a y-intercept. So y equal to 2, it's a positive 2. We're right here. Sorry, not there, sorry. That's your horizontal line, I'm sorry. Sorry, I got carried on when it says x. It's a horizontal line at 2. So if I were to graph this, this is the graph of y equal 2. It's a horizontal line that it's passing through 0, 2, because it's a y-intercept. So this point is 0, 2. The intercept there. But I don't want the whole thing. It's only when x is greater than 0. So where's x is positive? From here on, x is positive. So only part of the graph. So I don't need all that. It's gone. Now it doesn't have an equal sign, so it's going to be open circle. So what did we say? One of them is closed circle. The other one that carries it on, it has to be open on the top of it. So if I look at my open interval notation here, I'm starting from negative infinity, walking here, and then I hit the graph. At certain point it stops. But then something carries it on, and then I'm going to continue to my positive infinity. So the domain is from negative infinity to positive infinity. Yeah, there's a stop and gap here. But remember, you're looking at for the x-axis. The domain is your x-axis, so there's no stopping here. Your range is different. So how are we going to record that? We're going to record these three functions separately. You're going to graph them separately. So first of all, you're going to take that f of x equal to 0. Or, if you want, change that f of x to y equals 0 so you can see it. Again, this is the special function, y equal to constant. That means your horizontal line. And horizontal line is the y-intercept at that. So here at 0, and here's my graph of y equals 0. It's the whole thing here. Y equals 0, then x is equal 0. It's a horizontal line that it's passing through the x-axis, through the origin, because is your 0 there. But if I look at the condition, this is x is less than negative 4. So not the whole thing. I don't want the whole thing. This is from negative infinity to positive infinity. That's not what this is saying. This is saying only for x is equal, it is less than negative 4. So if I look at the function again, I'm going to erase this and graph it less, not too much shaded like that. And then 1, 2, 3, 4. That's for x is equal less than negative 4. So here's negative 4. For any values of x that it's less than negative 4, I'm going to remember the graph is that horizontal line that is actually the x-axis, because y equals 0 is at the origin. The y-intercept is at 0, 0, and it's a horizontal line passing through that point, so it's everything on the x-axis. But I don't want the whole thing. Negative 4, I'm right here, an open circle, because there's no equal to it, and only the negative part of it. So only this part. Only that part of the graph. F of x equal to 0, for x is less than negative 4 is only that part. So I'm going to grab the second equation with red so you can see how they are different from each other. So now we're graphing f of x is equal negative x. Okay, so that's f of x equal negative x, or y equal negative x. Again, there's no y-intercept, so it's at 0. So I'm going to graph using a slope and y-intercept. So y-intercept is at 0, 0, right here. Slope is negative 1 over 1, so going down 1 and right 1. So here's my graph of that function. So if I were to graph y equal negative x, it's a negative slope passing through the origin. So I'm going to go here now and see what's going on. Can I graph, and if I graph this, this is from negative infinity to positive infinity. I don't want that. I can't, because that's what tells me where to start and where to stop. So they only want from negative 4 to 0. Remember, this is open circle, so immediately above it, it has to be open circle. I cannot have negative infinity because this is taking care of the negative infinity, and I'm stopping at 0, so I don't need that part. So this one has to be closed circle because there's an open circle. So above it has to be closed circle. See, this one doesn't have an equal sign. This one has equal sign at 4, negative 4. And then this one is going to be the open circle at 0. So the last functions we have, it's y equal x squared. And if you know how to graph y equal x squared as a parabola, there's nothing it's subtracted there, so it's at origin. So here's my graph of parabola that it's centered, or the vertex is at 0, 0. So if I would graph y equal x squared, it would be a parabola. Vertex at 0, 0. But I don't want the whole thing. It's only for x is greater than 0 or equal to 0. So anything that is negative, this part, I don't want it. It's not part of my function. Let me continue this one connected and connect this part. Okay, so only I want the positive part from 0 to positive infinity. Anything that is greater than 0 or equal to 0. So what happened here? There was an open circle for 0 here, but then this one's carried on, so you're just gonna make it closed, and you're done. See, you're coming from negative infinity, you stop at negative 4. Another function takes it from negative 4 to 0. Then another function takes it from 0 to positive infinity. So if I look at the domain, it's from negative infinity to positive infinity, because you're looking at the beginning and the end of the function. We call it an open interval, or the interval of the functions, of the function f of x. I'm looking from negative infinity to positive infinity. Yeah, there's spacing. There's pieces here going. But whatever happened. So what's a slope? And we write it with the letter M because it came from different languages, just like anything else in math. But what is it? It's actually change of y over change of x. What it mean is the steepness of the line, how that line is steep. So you're driving, for example, on a car right there, and then there's a street like this. So how steep it is? Can you walk down that way, for example? Can you go down that way nicely, no injury? Sometimes we'll talk about it. And for example, if you're like coming like that, and then you have something like that, of course you cannot go down this way. So the slope is the steepness of a line, how steep that line is. So we call it change of y over change of x. So change of y over change of x, you need two pair of points, which is x1, y1, and another one, it's s2, x2, y2. So change of y, you're going to subtract y2 minus y1, change of, okay, the difference of y over the difference of x, x2 minus x1. And that's our formula for the slope. You need two pair of points in order to find the slope for that, which makes sense because this is x1 and this is x2, and this is y1 and this is y2. So the first point is x1, y1, and second one is x2, y2. I'm going to pick 2 points on that graph and find their rate of change, we call it, rate of change for slope, to see how steep that line is. So you need 2 pair of points in order to find the slope. So what's a slope? We said y2 minus y1 over x2 minus x1. The common mistakes that I see, they put x on the numerator, y in the denominator. So be careful, it's change of y over change of x. And I'm going to name this one x1, y1, x2, y2. You don't have to. You can name this one x1, y1, and this one x2. As long as the ones goes together in one point, and the 2 goes for the second point. Or you choose this one to be your first point, this is second point. I'm going to substitute here. So that's 10 minus 7, y2 minus y1, and 8 minus 4. And then simplify. That's just a 3 over 4. That's your slope. What does it mean? What does it mean? So if this is positive, remember this is changing of what? That means I'm going up by 3. And this one means if it's positive, you're going right by 4. What if it was negative? Then you'll go minus 3, will go down by 3, and if it's negative 4, you go left by 4. So it depends on the sign. If they're positive, you're going up and right. If they're negative, you're going to go down and left. So your x1, y1, I already marked them for you, so we're going to substitute here. But be careful with this minus and the numbers being negative also. So negative 1 minus came from the formula. These are the difference of y, the difference of x. Minus negative 1. Be careful here. And 3 minus 4. So that's negative 1 plus 1 over negative 1, and that's 0 over negative 1, which is equal to 0. And if you look at it, there's no change of y. The y is the same point. So that means your line is the horizontal line. See, 1, 2, 3, 4 at -1, and 3 and -1. See, there's these 2 points. So what did we say? Do you remember when I wrote them here earlier when we were doing piecewise function? When you have a horizontal line, the slope is 0. We'll talk about this very soon when we come to these special 2 lines. Okay. Let's talk about another formula and how to find the line of the function. So do you remember when we had m equal y2 minus y1 over x2 equal, minus x1? If I would just cross multiply, then we will have y2 minus y1 equal m times x2 minus x1. This is called point slope formula. Why it's called point slope formula? You're using a point. Remember, this is 2 points, right? And you're using a slope. So we're going to choose 1 point and the slope in order to come up with an equation. So that's the equation, the formula that we're going to use. I'm going to write it up here and do an example. So we have y minus y1, or you can say y2 minus y1, as long as like these are different from each other. You know, these sub numbers, we just write them to tell you that these are different from each other. If I don't, that means this y is the same this y, and then I can cancel them out. But when I put these sub numbers there, they're telling me I have 2 different points, 2 different y's. Same thing for x minus x1. I just took the 2's out because it looks a little bit less writing there. That's why they take it out. So we're going to use that, and then let's do this. So if we have a slope given to me as 2, and it's passing through the point 3, 5. We need to use the given information to write the equation of that line. It's a line. Since they're talking about slope, the slope is only going to work for a line. How steep that line is. When you go to calculus, it's a different story. So let's see how to do it. This is your x1, y1. Do you see why I need only to name them x1, y1? Because you're going to be using only 1 point. The reason we named them x1, y1 and x2, y2 because we had 2 points. But when we're using this one, this formula and this idea, you only need 1 point and a slope. So I'm going to substitute it here. Remember, the slope is 2 over 1. And I'm named them x1, y1. So this is y minus 5 equal to x minus 3. I substitute it. So that's y minus 5 equal to x minus 6. Do the distribution here. Add 5 to both sides. Y equal to x minus 1. I found the equation of the line that has a slope of 2 and passing through the point 3, 5. So now we're going to do, there's 2 special lines that we have, and we call it horizontal line and a vertical line. They are 2 special lines. You cannot graph them using a table. You cannot graph using anything else. You have to memorize them. Every time you see these functions, immediately what comes to your mind is these 2 equations, these 2 graphs. So horizontal line, it's y equal plus or minus a b. Remember, the b came from y equal mx plus b. So it's a y-intercept. We're talking about that b. Usually for y-intercept, we write it for b. And x-intercept, we write it with x. Now, this is, we said, is a y-intercept. And it's intersecting at 0 plus or minus b, depends on where that equation is. But the nice thing is about it, we know that there's no change in the slope. So the line is a horizontal line like that. And this is your y-intercept. So it's a horizontal line. It's a y equal plus or minus. It starts with y equal to constant. It's a y-intercept, and here's the y-intercept point is, and the graph will be horizontal, but the slope is 0. While this one, the vertical line, is x equal plus or minus a. We write for x-intercept with a. For y-intercept, we write them with b. And this is your x-intercept. And it's a plus or minus a with 0. That's how we write x-intercept. But the slope is undefined. Why? Because the graph look like that. There's no steepness of that line. So imagine if you're coming this way, you're not going to go down of that line. That doesn't exist. And if I pick 2 points, for example, a point here and a point here, and find the difference, then you will have whatever that number is, and there's no change of x, so it will be divided by 0. That's why you end up with undefined. While here, if you take these 2 points, for example, so you have whatever, there's no change of y, and whatever the number in the denominator will be for x, so 0 over anything is 0. That's why it happened. So the steepness of the line there, it doesn't exist. While this one, you're driving or walking in a straight line, there's no elevation in it, so it's 0. There's no steepness to it. So that's the 2 lines that we're going to talk about now. So I'm going to graph it just with another color so you can tell the difference. So when I see y equal to a constant, I know it's a horizontal line now, and it's intersecting at 0, -2, and it's a horizontal line. So intersecting means passing through. So 1, 2, horizontal line, passing through 0, 2. Label your intercepts all the time. Here we go, I graphed it. While this one is -2, 0, and it's a vertical line. So the graph, it's passing through the -2, x is equal -2, right here, and it's a vertical line. Label the intercept. X is -2, y is 0. Always label the intercepts in these 2 functions. So what's the slope here? 0. What's the slope here? Undefined. Remember this because we're going to need it. So what's the standard form of a linear equation? ax plus by equals c. That's your standard form of linear equation. Y equal mx plus b is your slope-intercept form. So we're going to go back and forth between these 2 equations, how to write them in this form. So if I have 3x plus y minus 5 equal to 0, the question says write the, or this one sometimes they write the c here and equal to 0. So it's like ax plus by plus c or minus c equal to 0. So it's still in a standard form of linear equation. They want us to write the standard form of linear equation back in a slope-intercept form. So you see y is by itself and everything gets moved to the other side. That's what we're going to do. First we're going to add the 5 to both sides. So we have 3x plus y equal 5. You don't have to. You could have got rid of the x first. And then we're going to get rid of the x. Such that y is by itself. So y equal, and x comes first. So I'm going to move this term to the front and then add my constant. So now I rewrote my equation from standard form back to the slope-intercept form. So get rid of the constant first if you want, and then get rid of the x. You have to get rid of these 2, so you can leave y by itself. Now I need to get rid of this 3, so I'm going to divide every single term by 3. Y equal -2 over 3x plus 6. So we're going to graph this function using slope and y-intercept. Well, it's in a standard form, so I'm going to copy exactly the same steps that we were doing earlier. Subtract 6x from both sides. We get -2y equal minus 6x. Sorry, I forgot the -12. Don't skip steps. Sorry, it's just my bad habits. Then add the 12 to both sides. -2y equal -6x plus 12. Divide by -2 every single term. So we get y equal negative is positive, 3x Negative, positive is negative 6. So I found the equation of the line in a slope-intercept form. And that's what they want. They want us to graph using slope and y-intercept. So I erased all that and I moved the function after we wrote it in a slope-intercept form on the top. Now we need to graph using a slope and a y-intercept. My slope is 3 over 1. You can make anything into fraction by making denominator 1. And we need the rise over run. We call it rise over run, or change of y over change of x, or the difference of y over the difference of x. But we call it rise over run. So rise, you're going up or down. You go up and down, but you're running back and forth, right and left. That's the difference between them. So let's see how to do it. And then my y-intercept, it's 0, negative 6. So let's see how to graph these. You can start with a y-intercept. Sorry, let me write the negative 6 more up here so we can have enough room. 1, 2, 3, 4, 5, 6. Label your intercept. Start with a y-intercept. Rise over run, it's positive 3. From your y-intercept, you're going to go up 3. 1, 2, 3. So you're going up 3. So we're going up for this one, right for this one because it's positive. So I went up 3, positive 3. And then right 1 from the point that I stopped. Right 1, here's the point, connect them. Here's the graph of the function using slope and y-intercept. So we're going to subtract 6x from both sides. So we get negative 9y minus 18 equal negative 6x. Then we're going to add 18 to both sides. See, it doesn't matter. You can get rid of the 18 first and then the 6x first, whatever you want. It's the same thing, same steps, plus 18. Get rid of the coefficient, so divide by negative 9. Every single term. Y equal negative and negative is positive. Divide by 3, it's 2. Divide by 3 is 3x. Negative and positive is negative. 18 divides 9, it's 2. So here's my new equation. We're going to graph it now. Start with a y-intercept. Y-intercept is at 0, negative 2. Always starts with a y-intercept. Your b is the y-intercept. Y equal mx plus b. You remember the m is your slope. And your b is the y-intercept. And it's at 0 plus or minus b, depending on that sign what it's going to be. So 0, negative 2 is your y-intercept. Label it, bubble it there. Then go to your slope. 2 over 3. 2 is positive, that means we're going up 2. So from here you're going to go up to 0 counts. So 1, 2, you're going plus 2, up 2. Okay, so I'm right here. I went up 1, 2. And then a 3 to the right. So if I'm right here, starting from my y-intercept always. Then read your numerator, up to 1, 2. I went up here, now I'm walking up here. Now I need to go 3 right. 1, 2, 3. Connect these 2 points. Here we go. You graphed.